All right, welcome to Chapter 10 of the second semester review session. This is Chapter 10 on circles. What is the equation of a circle with a center 4, -6, and a radius of 3? So we need to come back to the basic equation of a circle. And this is the transformational equation. We call it the transformational equation because it has this nice little h and k, which allows us to slide the center of the circle around. But do notice that there is a negative already in the formula. And since there's a negative in the formula, when I plug a -6 in, it's going to end up being positive. But let's go ahead and rewrite this. So it's going to be x minus h, and h comma k is our center. So h is 4. And the y minus -6 squared. And then the r is going to be our radius of 3. So that's going to be 3 squared. One of my students showed me in something that their teacher had told them that this negative parentheses negative kind of looks like a plus. So I figured I'd just show you. He said you just do this right here, and negative negative becomes a plus, which is true. I wouldn't get too stuck on little tricks like that, though. Okay, so our final answer is x minus 4 squared plus y plus 6 squared equals 3 squared. And you could put that as 9. It'd be fine. All right, so 10. Let me clear the ink. It'll be online. What is the center and radius of the circle whose equation is x plus 3 squared plus y squared equals 64? So I'm going to rewrite this x minus h quantity squared plus y minus k quantity squared equals r squared. Now, if you're worried about memorizing that, remember we always have formula sheets, and a lot of these formulas are on those. So in this case right here, we've got x minus h squared, and that is actually going to be written as x plus 3 squared in the problem we have. And y minus k squared, I'm just going to put a parentheses, it's just a y squared at this point. And then r squared is 64. So now I'm going to try to do a little deduction here and figure out what parts had to go here, here, and here to get this, this, this. So let's start with the first one. What had to go in for negative h to give me a positive 3? Well, like we saw in the previous one, if I put in a negative and a negative, I end up getting negative is positive. So negative times negative is positive. So that means this is probably x minus a -3 squared. And here I've got this blank spot, but it was supposed to be minus k. So what could I put in there that's negative or minus that would leave a blank spot? Yeah, 0. And then this is r squared equals 64. Well, so that's really just going to be what is the square root of 64 squared? And the square root of 64 is 8 squared. So now we know that the center is the point -3, 0, and the radius equals 8. Oh, well, if I'll be a monkey's uncle. If you met my nephew, you'd think he was a monkey. Okay, C is the center of the circle. Find the length of arc ABP and the area of the small sector. Now, this will be where I differ from your teachers if you're not Mr. Conaway's student. Yes, there are formulas for this. I think it's kind of archaic to try to memorize these formulas when you can just figure it out using proportions. So, this is going to be a proportion where we're going to talk about the partial the partial of something divided by the whole of something. So part is to whole as part is to whole. Now the only thing is we got to figure out what parts we're going to deal with and what wholes we're going to deal with. It looks like we have a degree here. So the partial degrees divided by the whole degrees. And then we also, let's see, they want us to find the length of the arc. So the partial length over the whole length. So start plugging this in. What's the partial degrees? It's 38 degrees. How many whole degrees do you have around a circle? 360. And then the partial length, well, but 7 inches is the radius. We're talking about the arc length here. We're talking about the arc length. And what word do they put in front of length of arc here? Find. So we don't know it, right? So the partial arc length is the one we don't know. So we're going to put an X in for that. What's the whole arc length around a circle? What do we call that whole length all the way around a circle? Circumference. Do we know the formula for circumference? So what is the formula? 2 pi. And do we know what the R is in this case? 7 inches. So really the whole is going to be the circumference around the circle. Now we can do our proportion. We can cross multiply and solve. Degrees divided by degrees are going to go away. When I multiply this out, I'm going to get 14 pi inches down here. And instead of cross multiplying both crosses, I'm just going to do one because I don't need to do the other direction. So this is going to end up being 14 pi inches over here. And remember, I'm not doing any mystical magic when I do that. This is really just multiplying both sides by the same thing. This is the classic golden rule of algebra. If I multiply the two sides, then those cancel out. And that was already gone because it was replaced with this. Okay, so 14 pi inches times 38 over 360. It looks like we can do some reducing. If I reduce a 2 out of that, this is going to be 180. If I reduce a 2 out of this, this is going to be 19 over 90. I believe 7 and 19 are both prime over 90. Hold on just a second. Okay, so 7, I basically end up having 7 times 19 over 90 equals X. Oh, and don't want to forget my pi and my inches. So pi inches. And if I do that, what's 7 times 19? 70 plus 63 is 133 over 90. I'm going to move up here. X equals 133 pi inches divided by 90. Guys, I would just leave it like that. There's no way to reduce it. At this point, you could plug it in and find decimals, but what would it be? Can somebody put that in their calculator? What is 133 pi over 90? Any calculator? Do I need to hit the pause? 4.64. What is it? 4.64. That's approximately 4.64 inches. Okay. Okay, so now I'm going to clear this and we're going to find the area. So we're going to do the same thing. We come back to part over whole equals part over whole. Now, remember there's two parts here. One is the setup. The other part is the algebra. Now, if you're getting lost in the algebra, then that's a whole nother discussion. But the setup is the geometry. So what we need to look at for geometry is how do I set these up and say what's the parts, what's the wholes? Well, I always like to come back to what partials I have. One of them that I do have is 38 degrees. So if I do the partial degrees to the whole degrees, Then I want to do partial area to the whole area. So when I write this, I'm going to get 38 degrees over 360 degrees equals the partial area, which we can call y in this case, since I already used x, over the whole area. What's the formula for area? Pi r squared, and the r in this case is 7 inches squared. Okay, I'm done with the geometry side of this. The setup is done. Everything else is algebra. Everything else is algebra. Yes, ma'am. Hold on a second. Thank you for bringing that up. All right, 4.64, we need to go back and find ABP. 4.64 inches is the length of AP. That's the length of AP. And we will go back and find ABP by subtracting that from the circumference. So we're going to say circumference, which was 2 pi r, minus the 4.64 inches is going to give me the measure of ABP. All right, so let's go ahead and finish this out. We've got 38 degrees over 360 degrees, and I've got 49 inches squared. Pi on the bottom here. Times pi. So now I'm going to multiply both sides by 49 pi inches squared. And these two are going to reduce to 1. That's gone as well. And I'm going to reduce what I can here. Let's see, 360 and 38. Once again, that's going to be 19 over 180. And I don't, this is 7 times 7. 180 is not going to have any 7s multiplying into it. So there's really nothing else to reduce here. I need 49 times 19. So that's going to be like 49 times 20, right? How much is 49 times 19? 931. So this will be y equals 931 pi inches squared over 180. And then once again, you can find what that is, the approximate. So put that in your calculator and find what the approximate is. 931 pi divided by 180. I don't see anybody doing it. 16.24. Okay. Now that one is the correct amount because they did say the small sector here for the area. The other one, let's go back and find the circumference. Circumference was 2 pi r, which in this case r was going to be 7 inches, minus, what was this before we converted it to 4.64? Anybody have that written down? 133. Okay, and that was also inches. So I can put these together and I can say this is going to be 14 pi inches minus 133 over 90 pi inches. And put this in your calculator. 14 pi minus 133 over 90 pi. And it should be able to give you, well, let's just do this. 90 over 90. What's 90 times 14? That's going to be 900 plus 360, so 1,260. 1260 minus 133 is going to be 1160 minus 30 is 1130 minus 3 is 1127 over 90 pi inches. And let's see, is 1127 going to be divisible by 3? 7 plus 2 plus 1 plus 1, no, that is not going to be divisible by 3. I don't think 1127 over 90 is going to reduce. So you can give me what the approximate of that is. What's the approximate of 1127 over 90 pi going to be? 39 point what? 0.33 inches. 39.33 inches.
Okay, so is 16.24 the area of...
Yes, 16.24 inches squared is the area of the small sector, and 39.33 inches is the measure of arc ABP. Okay, I'm going to pause this one.